Hey, welcome back. So today we're solving valid braces, which was very similar to the valid parentheses challenge that we solved last time. So this one, instead of only having one sort of pair of characters, the sort of normal parentheses characters, now we're also including brackets and curly braces. And so this is now what counts as valid and invalid. So we've got open and close, open and close, open and close. That's true. They can be nested arbitrarily, but they don't match the sort of different kinds. The curly braces need to match the curly braces. The square brackets need to match the square brackets, and the sort of regular parentheses need to match regular parentheses. And then they have to be in the right order. So you can't have sort of these intersecting like open things. So you need to close. In this case, you would need to close the second parenthesis before you close the square bracket here. So this one is invalid because they have like this overlapping region. So it can be inside. That's okay, but not like one starts and then the first one closes first. And then this is just like a longer invalid example. So the strategy that we did last time, I think, was to we counted. We kept a count of the number of open and closed parentheses, or it was really the number of open, and then we incremented on open and then decremented on close, and it was false if we ever dropped below 0, and false if we weren't at 0 at the end. This time, that same strategy, we can imagine trying it for keeping a count for the each of the different kinds of brackets, but I think that that's going to go wrong because it won't keep track of the order. So this case here where they're not allowed to have this intersection, this overlap, if we have a count, so if we incremented the count for the square bracket and then incremented the count for the regular parenthesis and then decremented the count for the square bracket and decremented the count for the regular parenthesis, if we would get through this entire string and nothing would be wrong. It would have returned true for that if we applied that strategy sort of extended to braces. So instead, we're going to have a different strategy for how we approach this. And the strategy for this kind of problem, where there's sort of this tracking of what's currently open and closed, the strategy is to use a stack. Instead, use a stack. So in JavaScript, we're going to use an array as a stack. It has the push and pop methods, which are what a stack needs. And so what we're going to do is we're going to create a stack of the opened parentheses, and this will be just an array like this. And then just like last time, we'll loop through the parentheses. So for let brace of braces, when we encounter one of these braces, if the brace is an open or the brace is this kind of open, a square bracket open, or the brace is a open curly brace, and we're going to push that onto the stack. So if we just imagine our stack over time, if we take, maybe we take this example. So this is our string, and we're going to imagine our stack over time. So first, we've got this open irregular parenthesis, and we'll push that onto our stack. So this will look like this. The auto closing parentheses feature in this editor is really making things worse, not better. Okay, so this is what our stack will look like first, and then we'll get to the next character. So we'll go to this square bracket, and we'll push that onto the stack as well. And the basic logic of this program will be that if we encounter a closing bracket, as we will in a couple of steps, you can sort of see that we're going to add the opening brackets. When we encounter a closing bracket, we're going to pop from the stack and check that it matches. So whatever the top thing is on the stack, it has to match that closing bracket. So sort of the most interior thing has always got to be a match for the last thing on the stack. And then when we pop this thing from the stack, then we'll be on the next thing. So we'll see a closing thing, and so we'll pop from the stack and check that it matches, and then we will the stack will be back down to this. It'll just have those things on it, and then the next thing that we'll see will be the closing bracket for this one. And if you sort of work through all of the different possibilities for what you could see as you go through this, the properties of popping and matching on the stack conform exactly to this specification of like a valid set of braces. So every time that we add an opening brace, we'll eventually need to close it, and then that closing brace needs to match whichever thing is on the top of the stack. The other thing that we'll need to do is at the end, we'll have to check that the stack is empty, that all of the braces have been closed. So if we're one of these opening braces, then we're going to open to push the brace. Otherwise, we're going to say the top of the stack is the opened pop. So we're going to pop this from the top of the stack, and then we need to check that the brace matches its sort of counterpart. So this is sort of another case where we need to have some sort of matching up of like which brace goes what. There's actually, let's just sort of think through how we want to do this. So we're going to do some kind of like, if the top is this opened one, and the brace is the closed one, then that's good. You can go ahead and continue. And then we need this same logic for each of these other ones. Otherwise, we're just going to go ahead and early return false. So if the top of the stack was this, we need to make sure that the brace is this. If the top of the stack is this, then the brace needs to be this. And if it's none of those things, then it's like we didn't match the brace. We had like the wrong closing bracket, and so we have to return false. We'll come back once we've checked that this solution works and see if there's a way that we can clean this up a little bit. Okay, so we're going to go and make this check at each time. We're popping off the top of the stack and pushing onto the stack depending on whether we're opening or closing a brace, and then we have to do this final check. So we want to return is the opened length 0. So if we've sort of finished if we've closed all of the brackets, then it's true. If we haven't, then it's false. Let's run the tests and see. Okay, so this is passing the sample tests, and if we go ahead and click attempt, it's also passing all of the other tests. I think that it could be we could make this a little simpler if we do something a little bit clever here. So so for this refactor, what I'd like to do is sort of have the matching brackets just sort of extract out this logic into like a data structure rather than having all of this, having all of these ifs all over the place. So what I'm going to do is I'm going to have an object that has the matching brackets, and for we'll just sort of copy in all of this, and I'll do some deleting. So so for the open parenthesis, the matching thing is the closing parenthesis. And the same is true for the square brackets and for the curly brackets as well. So now instead of checking sort of all of this logic, we could check if matching brace. So if the brace is in this sort of the opening set, then this will be defined, and if it's not, then it'll be undefined, which is falsy in JavaScript. So then we get this, and then we can simplify this logic too, and we can say if the matching bracket for the top is the brace. So if we look up the top bracket and it's the same as the current closing bracket, then we can continue. And we just sort of cleaned up this logic. Just like any time that you do a refactor, good to run the tests again and just make sure that the logic is still valid. And let's run the full set of tests just to make sure. And I'm going to sort of also just delete some of these comments. And I guess in theory, while we're cleaning up, we can pull this set of matching brackets out to the top level rather than declaring it each time we run the function. So that's all of the cleanup. Let's just run the test again, just for, I don't think I messed anything up when removing the comments, but always good to check. And then we can submit that solution. As always, I encourage you to take a look at the other solutions that other people submit. There's always some interesting choices and different ways to solve a problem like this. We'll probably see some other stacks. It looks like this is a stack. This looks like it is using a regular expression to constantly replace the innermost set of brackets. It's sort of interesting. And then this is doing sort of the same thing except using an index of instead of the regular expression, but constantly replacing like the innermost pair of brackets with the empty string. So if you keep doing that and eventually get to an empty string, then you know that it was valid. Seems like a fine way to solve it. And this is using a bunch of case statements to do the same solution as the stack solution. This is doing that same, replacing the innermost string. And here's another stack. This looks like a stack, but this is maybe doing something. Ooh, yeesh. This is, I think, doing a stack-based solution, but it's doing it via the JavaScript array reduce method, which is a little bit hard to follow, just because this is sort of changes the way you have to think about the loop. Cool. So there's a lot of different ways to solve this problem. Hope that you tried this on your own and found a good solution. If you found a solution that is you think is particularly interesting, definitely be sure to share it. Thanks for watching.